Question 6 in the 2021 VCAR chemistry exam, and we have a question about denaturation, which is proteins. So, which of the following quickly identifies the bonds that break in a protein when it undergoes denaturation and when it undergoes hydrolysis? Well, hydrolysis is splitting up the primary structure, so therefore it's going to break the covalent bonds, so it's not going to be these two. In our denaturation, we're breaking the secondary and tertiary and quaternary structures, so therefore that is going to be covalent disulfide bonds, that could happen, but hydrogen ionic seems to be better in my opinion, so it's going to be D. Alrighty, so therefore my answer to question 6 is D, because denaturation is splitting the secondary, tertiary, and quaternary structures, which are mainly the interactions between the side chains for us, these two, and our secondary structure is broken between the amide linkages and hydrogen bonds between them. So therefore, answer there is D, because the hydrogen bonds will be our secondary and our ionic bonds will be our tertiary structures, not just covalent bonds, a lot of other intermolecular forces as well. Moving on to question 7. Consider the following characteristics of electrolytic and galvanic cells. Electrolytic is a recharge, and galvanic is a discharge, and electrolytic is where you're putting energy into it. So what happens? Electrolytic cathode is negative in electrolytic cells, that's true. Cathode is positive in electrolytic cells, that's true. Have non-spontaneous reactions, that's true because we have to pump electricity into them. Have spontaneous, that's true because energy comes out of them. Reduction occurs at the anode, that is not true regardless. And reduction occurs at the cathode here, that is not true. Reduction occurs at the cathode, that is true. Always, red cats are happy and in galvanic cells and sad in electrolytic cells. Moving on. They produce electricity, that's not true. They consume electricity, that is not true either. It is the opposite. This one consumes electricity because we recharge our cells, and galvanic cells produce electricity, so therefore it'll be that way. So it's going to be options 1 and 2. So only 1 and 2 is A. The answer must be A. Let's move on to part 8. On question 8, we have a triglyceride shown here. So what have we got here? We've got, which of the following statements about the triglyceride is correct? Okay, the fatty acids from the triglyceride will not undergo oxidative rancidity. Oxidative rancidity happens to, I think, all fatty acids in my opinion, but mostly carbon-to-carbon double bonds. And what have we got here? We've got this guy is C18H36 if I was a fatty acid, and therefore it is going to be saturated, so no carbon-to-carbon double bonds. This guy here is C20H40, so therefore again no carbon-to-carbon double bonds. This guy here is C18H34. The reason I'm saying H36 here is because this would have an OH coming off the structure here, so therefore I can say it's going to be CH36 because it's going to be this one plus 1 from over here. And the carbon is in a carbon here as well, so that's why it's 18 and not 17. But anyway, this one has 1 carbon-to-carbon double bond, so I'm going to say that therefore this one is not going to be right. Let's move on to the second one. The triglyceride will hydrolyze to carbon dioxide and water. That is true because hydrolyze, no. It's going to oxidize into those two. It's not going to hydrolyze. Hydrolyze is where we are going to break this up and we're going to form glycerol on one side and fatty acids. So it's not going to be B. The triglyceride has 3 carbon-to-carbon double bonds. That is not true. It's only got 1 from here, so it's not going to be that one. The triglyceride is insoluble in water. That makes sense. Triglycerides by definition are fats, so therefore they're going to be insoluble in water. So even regardless of these 3 here, D is definitely going to be right. Let's move on to question 9. An electrolysis cell consumes a charge of 4 coulombs in 5 minutes. This represents the consumption of how many electrons? Alrighty, so charge is Q equals IT. So therefore I can find my I from that because I know Q and I know T. So I equals Q over T. So therefore is 4 divided by 5 times 5 minutes, which is 5 times 60, equals, get my calculator, clear whatever that is, and 4 divided by bracket 5 times 60 gives me 0.013 amps. I don't need to do that. I need to know the electrons, so therefore Q equals number of moles of electrons times F. So therefore I'm going to find number of moles of electrons is Q over F. So it's 4 divided by 96500, and therefore that equals 4 divided by 96500 gives me 0.00, sorry, 1, 2, 3, 0, 415. So move my decimal point 1, 2, 3, 4, 5 points. So it's 4.15 times 10 to the power of negative, what do I do? 1, 2, 3, 4, 5. 5. Answer is going to be A. There. So again, just basic working out of using my Faraday's calculations. Read the question and you work out which one to use, but not a bad idea to write them all out just to find out what's going on anyway. Moving on to question 10. A student hypothesized that polishing the zinc Zn electrode in a galvanic cell would increase the current produced in the cell. What would be the most valid method for testing this hypothesis? All right, so we're polishing the zinc electrode. We want to know increase the current, so therefore researching the scientific literature to determine how polishing that's probably not the best way of testing something. Measuring the conductivity of a zinc electrode after polishing it. Conductivity, it kind of sounds like current to me. Let's move on. Measuring the change in mass per unit time of the Fe electrode in the same before and after. That's probably a good idea. Part B didn't say anything about knowing what happens when it wasn't polished. So C is looking good. I'm going to cross off that one. I'm going to say that one doesn't sound right because we're only measuring it once it's polished. Part D, measuring the current produced by two different galvanic cells, one polished electrode and the other using an unpolished electrode. That probably doesn't tell you if it's the actual zinc electrode or if it was the polishing. This one here sounds like it's the same electrode, so therefore that's going to reduce your problems with validity because in this one you're actually introducing another variable. So it's going to be C as the right answer there. And that is question 10. Done.